Guys, welcome to the first lecture module in Standards and Solutions. And the reason that you're watching this is because I'm not going to take anything from granted, right? I know that you probably, in the past, have had a pretty lousy, sucky chemistry teacher, right? There's a chance of that. Now, some of you maybe got lucky and you got a really good one and you understand everything that was presented in Chemistry 151 and 152 that you might have taken up to this point. But I also know that some of you weren't as lucky, and maybe you got an instructor that really didn't explain anything or work out any types of problems as far as the math was concerned in the course. And that's the whole purpose of me, right? That's why you're taking this class. So I'm not going to assume anything, nothing. I'm almost going to treat you like you would be in my class with Chemistry 151 or 152. So with that said, there's going to be certain parts of the lecture module that you could probably fast forward if you are comfortable enough with the material. So for instance, the very first set of videos that you are going to watch and take notes on and do an assignment on is going to concern formula weight. Now, if you're okay with calculating formula weights of compounds, then my advice is to skip me. Just go straight to the assignments and start completing them, right? But these videos are for those students that have not taken Chemistry 151 or 152 up to this point, and maybe they want to learn how to do this properly for the first time. Because let's look at it. There's no prerequisites of those classes in order to take 150. Well, maybe you need a review. Maybe you talked about it, maybe it was a little while ago, and maybe you need to go back and revisit some of these math problems. And if so, that's okay. Watch the videos, that's why they're here. So the very first thing that we're going to talk about is formula weight, and I'm going to abbreviate that with FW every single time. But you know what? Formula weight can also be called molecular mass. Both of these go under the same kind of category. You solve them the same way. They kind of mean the same thing in a way. Molecular mass is MM. And you can also see molecular weight, and that would be MW. So no matter how the problem is worded, you're basically going to do the same process in order to solve these types of problems. So what we're going to do is that we're going to just do example after example after example of formula weight. That's really how this lecture series is going to be set up throughout the entire semester and the course. I think by doing that, I trim away a lot of the fat. I allow you to focus on one topic only until you get comfortable with it, and then you perform much better on these problems. So let's do an example problem. And the example problem is to calculate the formula weight, and that's gray, you can't see that color. Calculate the formula weight of C2H5OH. Okay, so this is how we calculate formula weight of any type of compound. It doesn't matter what it is. Now, this is going to take up some room, and that's okay. That's what paper's for, right? Eventually, you'll get to the point where you can just pop this into the calculator and be able to crank out answers without a problem at all, right? But in the beginning, I need to show you where these numbers are coming from. All right, so if we look on the periodic table and we try to find carbon, here's the table. And carbon is right up here at spot number 6. Now, depending on what type of table that you have, and this is different, but that's the atomic number. That's typically the number that's on the very top of many of the periodic tables that you will see in our own laboratories, right? And even in periodic tables in a textbook. This one, though, has a mass number, and the mass number is typically written at the very bottom. This periodic table is not, though, and that's why I'm picking it out to show you as an example. Tables can come in different formats, and you have to understand what these numbers represent. So 12 is the mass number, right? Now, up here in the scheme, it's actually going to show you an example, and it says the number in the right-hand corner in this table is the atomic number, And the number in the left-hand corner at the top is the atomic mass number. And that's the number that we're going to start using with formula weight. So when it concerns carbon, the formula weight is 12.0107. Now the question is, how do I know when to stop? Well, some people want you to carry out them all digits after the decimal point. Some periodic tables, they don't carry out this many number of decimal points. They only give you 2. And actually, to tell you the truth, most of the time in formula weights, they really only focus on 2 numbers after the decimal. Whenever you see these printed in literature, whenever you see them put onto a label of a chemical jar, most of the time it's 2 numbers after the decimal, and that's how we're going to leave it as well. So for carbon, because that was the very first thing that was in that formula, right? C2. I need carbon. I need to know how much carbon weighs because we're calculating formula weight. So I go to the periodic table, I find carbon. Up here at the top, I see 12.0107. I'm going to round that off, and I'm going to list carbon as 12.01. All right. Now, I'm not going to do anything with these numbers yet. I'm just going to write down the atoms that are involved. So I know I have a hydrogen, and then I know that I have an oxygen, and it looks like I have another hydrogen here. Well, I've already written it down, so why do I need to do that one more time? I don't. I just need to remember that that extra hydrogen is there so I can take care of it. So the next one is going to be hydrogen. So I'll go to the periodic table, and then I'll go up here to the table, and I'll look at the mass number, and maybe on your version, the mass number's at the bottom, and if so, that's okay, as long as you know where to find it. And the mass number says 1.00794. Well, I'm going to round that off, and I'll do 1.01. And then finally we have oxygen. So I need oxygen's weight as well, right? So I'll go to oxygen, 15.9994. So I'm going to round that off to 16 even. Rules of rounding. There we go. Now I need to take a look at this formula because my job is not yet done. I've got the weight of each one of these, but I've not counted how many of these I actually have in the formula, right? So this tells me that there's 2 carbons for every one of these molecules. That's what that little 2 down here means. So because there's 2 of those carbons, I'm going to have to multiply that weight by a 2. Okay, well, hydrogen's the same way. I see 5 of them here, but I get an extra one from that end one. Remember, I said don't forget about it. So there's actually a total of 6. So 5 from the hydrogen and 1 more from that one. So that's a total of 6, and I need to multiply by 6 in order to calculate the proper formula weight. And then finally oxygen, well, there's just one of those suckers, so I'm going to put 1 there, and that's going to be an easy calculation for me. All right, so now what I do is I get totals from each one. 12.01 times 2, well, that's going to be a 24.02. 1.01 times 6 is going to be 6.06. And then finally 16 times 1, and that's going to be 16 in total. Now those are the weights for each one of those atoms that I have, right? So now I need to bring up a calculator, and I need to add all of those up. Because in order to calculate the weight for the compound, you have to add up the weights of all the pieces that make it up, right? So 24.02 plus 6.06 plus 16, and I hit enter. And that gives me 46.08. So this is 46.08. And all of these are in grams per mole. That is the unit that formula weight or molecular mass or molecular weight carries with it. So that means 1 mole of this substance is 46.08 grams. Now, what is a mole? If you've not taken chemistry 151 or 152, you probably don't know what a mole is. Well, we'll get to that eventually. Right now, I just want you to think of this as a unit, and that unit means an amount. So I want you to regard mole as kind of like the word dozen. Dozen means 12. Doesn't matter what it is. It can be a dozen of eggs, a dozen of cats, a dozen of papers, a dozen of pencil, a dozen of students. It doesn't matter. Dozen equals 12. Mole is very similar. Mole is a unit. Mole represents an amount. What is that number? We'll get to that. That's not the purpose of this video. Remember, I'm telling you to trim the fat. We're only going to be looking at the meat. Show me the beef. And this is what I'm showing you. So this is how we calculate formula weight. Look at your formula that you're given. Break it apart in detail. Bring the molar masses from the periodic table. And then add them all up in the very end. Now, the reason that we're talking about formula weight is this class is standards and solutions, right? Well, standards and solutions, you're going to have to learn how to make them. And formula weight is part of that problem. You have to learn how to make solutions, which often mean you need to use the formula weights of these things in order to get there. Now, sometimes the formula weights, they are on the chemical label. So if you're lucky, and they really should be on there, somewhere you will see a formula weight that's printed. So in a laboratory, you don't really have to do these calculations. For the most part, all the new jugs will have the formula weight printed on the label somewhere. You just got to find it. You can also find the formula weight on search engines. So go to Google, go to whatever you want to use on the internet and type in formula weight or the molecule that you're trying to find, and you're going to be able to find a web page that has the formula weight already listed. However, sometimes this is not an option for you. Sometimes it's not on the label, and you're going to have to learn how to calculate formula weight on your own, and that's the purpose of these videos. All right, so let's do another one. We're going to calculate the formula weight of HC2H3O2. And we're going to do this the same way that we did before, right? That's all that these videos are going to be. One example after another, after another, after another, after another, until you feel comfortable doing what you need to do. All right, so let's take a look at these. I'm going to break it up into hydrogen. I'm going to break it up into carbon. I'm going to break it up into oxygen. Those are the three elements that are involved in this formula, right? So if I take a look at hydrogen and I go to the periodic table, I'm going to find 1.01 as a rounded number. If I go to carbon, I'm going to find 12.01 that's listed there. And if I go to oxygen, I'm going to find a 16. Well, now I need to bring in the subscripts. How many hydrogens do we have in total? Well, there's 1 from here and 3 from there. So that's a total of 4. So 1.01 times 4, 4.04. Okay, my carbons, there's just a 2 here, right? There's no other carbons anywhere else, so there's only 2 of them in total. 12.01 times 2 is 24.02. And then finally, my oxygens, well, there's 2 of those. That's what that little subscript means there. So 2 oxygens, that's it. So 16 times 2 is going to be 32. So now I take those and I add them all up in order to get formula weight. All right, well, if I clear out this calculator so you can follow through, 4.04 plus 24.02 plus 32, and I hit enter, I get 60.06. So 60.06, what's the unit? That's right, gram per mole. So there's 60.06 grams of this stuff in every 1 mole of this stuff. And that's what that unit means. So again, formula mass, molecular weight, molecular mass, doesn't really matter. Okay, so let's do another one. KClO3. All right, so I do it just like before. K, Cl, and O. All right, well, you're going to start using some of these over and over and over, and you'll just kind of learn them as you go. It'll kind of be like riding a bicycle. Once you learn them and memorize them, you'll never forget them. And we already know now, oxygen we've done twice, and we know that that formula weight is going to be 16. And it looks like there's 3 of these in total, right? That subscript goes directly for the atom that is in front of it, right? Not the Cl and not the K, but just the O. So 16 times 3, that's what's going to go there. All right, now chlorine, right? We've not used chlorine yet. So let's go to the periodic table and let's find chlorine. And chlorine's going to be right here at spot number 17. It's in the halogen group, and it's the 2nd row down, or the 3rd row down, excuse me. So chlorine's right up here at the very top, and we see that weight is 35.453. So I'm going to round this off to 35.45. And again, your number might be down here at the bottom, and that's normally where it is, honestly. And if so, that's the number that you use. It's the same number that I've got. Mine's just in a different location. So 35.45. So that's going to be for chlorine, 35.45. And there's only one of those in the formula, right? So I'm going to multiply that by 1. That's going to be an easy one for us. And now I need potassium. All right, so I go to potassium. Potassium is an alkali metal. The alkali metal group is here in the first column, and potassium is in row number 4, period 4. So potassium here is spot number 19. That's the atomic number, but the mass of it, that's what I need to use. So the mass of potassium on this table is in the top left. In yours, it might be at the bottom, but that is 39.0983. So I'm going to round that off, and it's going to round to 39.10. So that's the number I'm going to bring in, 39.10. Now, there's only one of those, right? So I'm going to multiply by 1, and that's easy for me too. So 39.1 times 1 is 39.1. 35.45 times 1 is 35.45. And then 16 times 3 is going to be 48. So now I add all of those up. So 39.10 plus 35.45 plus 48. I hit enter, and my answer is 122.55. So 122.55 grams per mole. 122.55 grams of KClO3 for every mole of KClO3. Notice what's happening here, right? Formula weight is very specific to the compounds. And these formula weights are telling you how many grams you need to hoard up in order to have 1 mole of that substance. In other words, it's almost like how many individual eggs, in this case, do you have to make 1 mole of that particular type of egg. I know that sounds kind of weird and kind of strange, and it go against the amount that I gave you a while ago, but eggs have nothing to do with moles. We're in chemistry. We're in lab, right? So mole is a unit. Mole means a specific number. That number is going to be related to an amount. So I need to weigh out 122 grams in order to have that physical amount of substance. And again, we'll talk about mole much later on. So here are just some quick examples of formula weight. In the next video, I'm going to do some more of them, and I'm just going to keep giving you example after example until you feel pretty comfortable with what we're doing. And the examples hopefully will get a little more complicated as we work through them. So sit back, relax. It's going to be all math, and that's really all that this course is. It's basically the mathematical processes that you need to know under your Batman utility belt, where you can make a solution from scratch on your own and not question what you're doing.